In this video, I'm going to go over example 4 on page 1113. Find the parametric representation for the sphere. X squared plus y squared plus z squared equals a squared. All right, well, in order to do this parametric representation, we're going to have to use spherical coordinates. We're going to go over spherical coordinates later on in the course, but I want you to know the spherical representation for a sphere, in this sphere in particular. So we're going to memorize this, and I'm just going to show you what the book has right now. So your R is got the parameters theta and phi. All right, so both these angles, and your X is alpha, I would say yeah, it's actually A. So A sine phi cosine theta, and then your Y is A sine phi, and then sine theta, right? And then A cosine phi. All right. So this may or may not be confusing for you, but I think that since we haven't gone over spherical coordinates in particular, let's just look at this. I'd like you to just make sure you understand what's going on. Looking at the sphere itself, all right. So let's just kind of draw the sphere. Oops, that's not a great drawing, but we can do it. All right, so we have a sphere of radius, right? Radius A. And then we're going from 0 for theta, 0 to 2 pi. And phi is actually just going from 0 to pi. Now, in polar coordinates, this sort of makes sense here. You've got your radius times cosine theta, and your radius times sine theta. That gets you your circle. And then we have the sine phi, cosine phi here. So we know that makes sense for the circle, but in spherical coordinates, we want to talk about the angle phi that actually measures the angle out from the x-axis. Okay, so this is your angle phi, and your phi goes from 0 to pi, so you're actually going all the way, your phi's all going all the way down here. Right, so you've got all these phi's, and also since it's measuring the angle out from the z-axis, it also will hit the whole sphere. Okay. So you can imagine that this makes somewhat good sense, in which that sine phi, a sine phi, and a cosine phi would basically make a sphere. All right, and again, we're going to go over this in the next few modules, but let's just kind of memorize what we have here and work with it for now. One thing I want to do here is actually check that this is a good representation, so a good parametrization. So let's check. So we know that x squared plus y squared plus z squared equals a squared. So let's go ahead and plug in let's plug in our parametrization. I'm going to go ahead and do that. So it's a squared sine e squared cosine squared theta plus a squared sine e squared sine theta squared plus a squared cosine squared v. Now all this should equal a squared. So what I'll do here is I'll look at this first part, pull out a squared sine v, and we end up here with cosine theta squared plus sine theta squared, and bringing down the a squared cosine squared v. We know that this equals 1, so we've got a squared sine v squared plus a squared cosine squared v, and we know where this is going. So we're pulling out a squared, and we get sine squared v plus cosine squared v, which will also equal 1, and we get a squared. So that is a good parametrization of the sphere. So if you are a little confused on how the phi works out in forming the sphere, you know with confidence that R, the spectral representation of the sphere, is true.